Method, technical, model analysis. The ideal model in the numerical model refers to having the perfect setup to perform the test in the most efficient and effective manner. Within this section, I will be analysing the perfect methods for both the three-quarter court sprint and the vertical jump when comparing the ideal to the method that we actually were able to perform when conducting the experiments ourselves. Beginning with the vertical jump. The vertical jump test is used to measure and determine a subject's power as they jump as high as they can vertically straight up, propelling themselves off the floor. When conducting the perfect model for the vertical jump, the most reliable equipment to utilise would be a force mat. A force mat is a piece of highly complex equipment which is fitted into the floor, which measures any external pressure which is applied to it, e.g. a person jumping on it. A reason a force mat is the most efficient technical model is because it is capable of measuring ground reaction force, the force applied upon the floor, up to 1,000 times a second, creating extensive data, providing surplus amounts of data to perform an in-depth technical analysis upon every stage of the individual's vertical jump, with the ground reaction force being presented in newtons. As an example of a force mat reading is presented above alongside by a step-by-step vertical jump. This is on the left-hand side of the slide. If we follow the force mat reading, we can see that the readings start off at 0, as the force would have been calibrated to the subject's individual weight. So it's set at 0 to begin with, following the initial stage. So we can see the ground reaction force that the ground reaction force reduces as the subject bends down, in accordance with the image above, as the centre of mass becomes lower, after which the subject jumps up, propelling off the floor, creating a massive burst of ground reaction force as the subject applies their bodily force into the ground as they propel upwards. As the floor applies the equal opposite reaction force upwards in response, causing them to jump up, triggering the massive spike in ground reaction force. Following the large propulsion force, the ground reaction force momentarily becomes 0 as the subject is aerial. This is because, as in when they're in the air, they'll be applying no pressure to the mat. However, as soon as the individual lands back onto the mat, a massive negative collision force is applied as the subject's weight, and downwards momentum is applied onto the floor mat. Finally, ground reaction force increases slightly as the subject recovers by bending their knees and lowering the centre of mass, bringing the force upwards slightly. Upon analysing this, it is clear to see that the force mats are an extremely complex method of measuring vertical jumps. However, the data you receive from it is unparalleled in its accuracy, reliability and validity, making it the ideal technical method for measuring vertical jumps. However, one downfall of force mats is their lack of accessibility due to their very expensive price tag. Most people cannot access force mats unless they have somehow gained access to a fully equipped sports lab, which most people cannot do, therefore making it an unrealistic style of measurement to be used by the general public. As a result, when we conduct vertical jump measurements, we used a different, more accessible measure method known as jump mats instead. Jump mats are more commonplace than force mats, as they are cheap and easy to use, making them very accessible for the general public. As we could not gain access to force mats, we were forced to use jump mats instead, which is less than the ideal gold standard, as force mats are significantly less reliable and accurate. The method for a jump mat is very simple. The first stage is to ensure the calculation machine within the mat is calibrated to 0. Then the waistband should be placed around the subject's waist. Following this, the subject should reel the cord around their waist until it is tight. Finally, the subject should then perform a stationary vertical jump by bending downwards and propelling themselves upwards. A reading for the vertical jump height will be presented. This measurement can be utilised to calculate the subject's exerted force by simply going to a power calculator online, such as powercalculator.com, and simply inserting the subject's vertical height and weight for increased, and then a power calculation will be provided. For increased reliability, the vertical jump reading can be taken 3 times and a mean average taken to improve accuracy and validity of the test.